Swayam Prabha. Digital India. Educated India.
Hello everybody, welcome to my course Reactive Intermediates, Carbenes and Nitrenes. So, in my last classes we were discussing about various type of reactions that is associated with carbene. We have discussed addition reactions, we have discussed insertion reactions, we have discussed different type of nucleophilic addition towards the carbene, and in the last class we have discussed different type of rearrangement reaction, okay. And in the rearrangement reactions we have understand that how that once the carbene generated, even though there are possibility of as per example that CH insertion, then still there is a if there is no beta hydrogen, how that carbene can proceed with the rearrangement reactions. Again today we will continue with this rearrangement reactions. One very important reaction is there that we will discuss first, then we will proceed. Okay. So, one of the most common feature in this type of carbenes, that is they are generally adjacent to a carbonyl group. Okay. So, the carbenes which is forming, if that is adjacent to a carbonyl group, then what will happen? Okay. So, under these rearrangement conditions that we will see, in general it has been seen that if there is alpha diazoketone okay. So, under thermal or photolytic condition, that will give the ketenes. Okay. And this is called, this is a very famous rearrangement, this is called Wolff rearrangement. Okay. So, what we said that if we take the substrate as alpha diazoketone, okay. Now, under thermal or photolytic condition, what it will form? It will generate the carbene. We know these things that during the preparation of carbenes or the generation of carbenes we have learned this. Okay. Now, this is the alpha ketocarbene. Okay. Now, if we have this alpha ketocarbene, the rearrangement can happen, okay. And if this rearrangement happen, then what it will generate? It will generate the corresponding carbene, will give you the corresponding ketene. Okay. So, we are starting from this alpha diazoketone and that is finally generating the ketene. Now, this ketene is ready for different type of reactions, different nucleophiles can attack to this center, okay. And once it will react, it will give different type of products. As per example, if you treat with water, the product will be the corresponding carboxylic acid, or if it attacks with alcohol, okay, then what will happen? If it attacks with alcohol, this will be corresponding ester. Okay. So, as per example here R prime. So, this will be the corresponding ester. So, in this way we can generate the ketene from alpha diazo this ketone, and that can proceed this after generation of this ketene, that can proceed to carboxylic acids or esters. So, this is called the Wolff rearrangement. This particular rearrangement is called Wolff rearrangement, where ketene is forming. Okay. So, once we have this Wolff rearrangement, now let us see if we take this particular substrate, this diazoketone compound as the carbene precursor. So, this will generate the corresponding carbene, and once it will generate the carbene under photolith condition. Okay. So, what it will form? So, okay, and fine, and once it will form this, here in this case you see there the ring contraction is happening. That means, we have started from 6 member, now after this rearrangement, this Wolff rearrangement, this become 5 member having this ketene. Now, this one in presence of water will give the corresponding carboxylic acid. Okay. So, here you see that we have started with 6 member ring and we are ending with a 5 member ring having this carboxylic acid. Similarly, if we take this fused ring as the substrate, okay. So, this alpha diazoketone if we take and under again photolysis, and here methanol is there as a nucleophile. So, what it will form? It will form, as we have already mentioned, that first it will generate the corresponding carbene, and now there will be the Wolff rearrangement, and once it will do the Wolff rearrangement, then it will generate the corresponding carbene, and I am not going into detail of that. And once that will generate the carbene, after that the methanol will attack to it, and finally the product will be again here we have started with 5 member ring. Now, it will ring contractions will happen and we will get the 4 member ring. See, this is a very interesting product because there are 3 4 member ring that is fused and with a ester moiety. So, we have started 4-4-5, but we came as a 4-4-4. Okay. Next, if we take a compound, bicyclic compound, this alpha diazoketone. Okay. So, this is having the corresponding bridgehead with dimethyl group. Now, again under electrolytic condition, then here water is as a nucleophile. So, as per our previous experience, we can simply make here alpha the corresponding carbene, and once this carbene, then this one will migrate. Obviously, here if you see this bond that is associated with another 2 carbon carbon bond, and where this bond possibility of migration of this bond is lower because here associated with one carbon as well as 2 hydrogens. Okay. So, in this case, So, this particular bond can migrate and the migrating aptitude will be higher here, and that will give the after that the nucleophilic attack of this water to the ketene moiety will give the 5 member ring from here, and overall the product will be okay. So, this is the 5 member ring with a carboxylic acid. All these cases whatever I have shown here, you see that we have started from more number of ring, but at the end we are decreasing and the ring number is decreasing, and overall if we start from 6 member we are getting 5 member, if we start from 7 member we are getting 6 member. Okay. Now, one of the most important synthetic applications of this wool prearrangement, we will see that, and what is that? If we consider this wool prearrangement, then we are starting from this alpha diazoketone and that is converting into the corresponding ketene, and different type of nucleophiles are attacking. So, now if we start with a carboxylic acid, okay, and we want to see the most important synthetic applications of wool prearrangement. Okay. So, if we want to see that, let us say we have started with this carboxylic acid. Now, one carbon homologation of this carboxylic acid is the main synthetic application of wool prearrangement. As per example, if you start from here, we are getting finally this one. Okay. So, how we are doing that? If we take this carboxylic acid, then we can, in presence of thionyl chloride or oxalyl chloride, okay, we can make easily this acid chloride. Okay. Once we have generated that, then in presence of diazomethane, that will react to this electrophilic center and give you the corresponding alpha diazo keto compound. Okay. So, we can write over here okay. Fine. Now, if we have this, once it is there, now this is ready to generate our desired carbene precursor. So, under thermal conditions again, now there it will form okay, and this can go for this wool prearrangement to give the ketene moiety. Okay. Now, if we have the water as a nucleophile, then actually what we are getting? We are getting the corresponding carboxylic acid with 1 carbon extra. Similarly, if we take R prime OH, that means alcohol as the nucleophile, then we will get the corresponding ester with 1 carbon more. Okay. So, we are starting from a carboxylic acid, or we are, and after that we are ending into 1 carbon homologated carboxylic acid or its corresponding ester, and this is happening through the wool prearrangement. this is one of the beautiful application of Wolff rearrangement, where one carbon homologation is possible from its corresponding carboxylic acid, and this is called and Estert homologation. Okay. This method is called and Estert homologation. Fine. So, in this way we can simply take one carboxylic acid and we can increase into its one carbon homologation to get the corresponding carboxylic acid or the corresponding ester. Fine. We will now see one of its applications of this and ester synthesis. Synthesis of grandisol. What is this grandisol? This is a sex pheromone from a paste of cotton bush, and this actually creating a lot of problem in this harvesting of this cotton. So, synthetically its application in agriculture field is enormous, because if we can synthesize this compound, then actually we can use this to attract this type of lot of paste. Okay. So, the paste that is generating this pheromone. So, we can attract those pastes and then we can eliminate them from the field. So, that is one of the important application for this type of pheromone, that if we can synthesize them. Now, what is its structure? So, it is having this cyclobutane ring and two stereogenic center. Okay. So, this is a sex pheromone from paste of cotton bushes and its name is grandisol. Okay. So, the precursor that has been taken from the cyclobutene derivative. After that, its conjugate addition from this Grignard reagent in presence of copper 1, the attack will happen over here, this 1,4 addition. Okay. Once this will happen, then the product will be the 1,4 addition product, and okay. So, once we have this, then in presence of lithium diisopropylamine, one very strong base, and the electrophile here is this methyl iodide we have used for the methylations, and the overall product will be, see, this is the here, this is the most acidic proton over here. So, what it will do, this base that will pick up the proton from here. Okay. Once it will pick up the proton, after that, that can again attack to the corresponding electrophile, and in that case definitely that attack will be the corresponding guided attack, and once it will be the guided attack, then this will give you the product of this one. Okay. So, once it will give this quaternary center, then actually here the ratio of 2 diastereomer 85:15. Okay. So, we have given this, obviously the other diastereomer also will form, but this will predominate, and once it has been synthesized, then the corresponding hydrolysis, basic hydrolysis with KOH potassium hydroxide. So, the ester will be its corresponding carboxylate, and after that the acid chloride followed by diazomethane treatment will give its corresponding alpha diazoketone. Okay. So, now we have this alpha diazoketone, it can be in presence of silver salt, and methanol is here as a nucleophile. So, that can give the 1 carbon homologation, because here you see now this will generate. Okay. So, once this will generate, so again this will some kind of Wolff rearrangement will happen. I am not going into detail of this, but overall once this will generate this ketene moiety, then the methanol will attack, and once the methanol will attack, after that it will give the corresponding 1 carbon homologated ester. Okay. So, what it will form after the ketene and corresponding methanolic attack, then it will form the 1 carbon homologated ester. Okay. Now, we have this ester, this can be now treated with lithium aluminum hydride, and in presence of lithium aluminum hydride, this will give the corresponding primary alcohol, which is actually our target molecule. Okay. So, in this way you start from a very basic cyclobutene moiety, and then followed by different reactions, first this conjugated addition, then this generation of this quaternary center, and after that the formation of this alpha diazoketone, followed by this Wolff rearrangement and the attack of this methanol will give this 1 carbon homologation, and finally, the reduction with lithium aluminum hydride will give the alcohol. So, this is a beautiful example about this AND ester synthesis. Okay. So, these are different type of rearrangements that we have seen in our last two discussion. Now, there are 2 reactions I will discuss that are very much important for the carbene chemistry. One is called Reimer-Tiemann reactions. Okay. So, other reactions from carbenes, among that Reimer-Tiemann reaction is very important. Okay. So, what is these reactions? In this case, actually the starting material is the phenol. Okay. So, phenol to its corresponding orthoformylations, that means we will get phenol to salicylaldehyde in presence of chloroform under basic medium. So, that itself tells that chloroform under this basic medium will generate the carbene species, and that will react with this phenol to give the final compound, that is the salicylaldehyde. So, what is the starting material here? So, the starting material here is the phenol, and okay. So, In this case, this is specifically the ortho substitution is happening through this dichlorocarbene. One of the important reason behind this could be the electrostatic interactions when this phenoxide forms, and in presence of that this when the sodium hydroxide or potassium hydroxides that generated this phenoxide that will form, and after that this dichlorocarbene that will give this corresponding ion pair, they are due to these electrostatic interactions that actually facilitating this ortho substitution. Okay. So, what could be the mechanism? The mechanism could be with presence of base this phenoxide, and then from here it can generate the carbene. Okay. So, this dichlorocarbene it can react. So, this will give okay. Now, this can pick up this proton. Okay. So, overall okay. Then the corresponding hydroxide attack, and further once this hydroxide will attack, chlorine will liberate, and finally that will give the corresponding salicylaldehyde as the final product. So, this will attack over here, and one it will liberate that Cl minus, and after that this will give you the final compound, that is the salicylaldehyde. Okay. And another reactions in this aspect with the carbene, considering the carbene reactions, if we not say that particular reactions it will not complete, that is called carbyl amine reaction. Okay. So, in this case the carbyl amine reactions, the starting material is 1 degree amine or primary amine, okay. And again in presence of chloroform under basic medium, that gives the foul smelling isonitrile derivatives. Okay. So, these isonitrile derivatives. Okay. So, here also it will generate this dichlorocarbene, and obviously this RNH2 that can react nucleophilic attack to this dichlorocarbene, and once it will give that. So, it will be this species. Okay. Then you can make plus minus H plus, that means this H plus can go over here, and overall what you will get okay. Now, nitrogen has this lone pair. So, can go out, then overall what you will get, that once it will go out. So, basically that will give okay. Now, this can nicely generate in presence of acid, in presence of basic medium. Okay. So, this can generate the corresponding isocyanide. Okay. Okay. So, we have started, there are two different type of reactions which is important for carbenes. One is called Reimark-Tiemann reactions and another one is called carbylamine reactions. In case of Reimark-Tiemann reactions, we have used this phenol which has been converted into salicylaldehyde in presence of chloroform and sodium hydroxide or potassium hydroxide, whereas in case of carbylamine reactions we have started with 1 degree amine that will convert into its isonitrile derivatives, and that is also going via this dichlorocarbene species. So, with this I am finishing the various reactions of carbene. Thank you.